Hello everyone, happy to see you here. Welcome back to my channel Hi Mathematics. Today we have a very interesting equation 5 to the power a plus 5 to the power a equal to 20. We need to solve this question for a. So if you have your solution, your answer, you can write your solution in the comments below and then we will check your answers, okay? So a lot of students may be thinking, okay, let's start for example with the inspection method. Let's see what will happen when we plug in to this question, for example, a equal to 1. Let's see, okay? So we have 5 to the power 1 plus 5 to the power 1, okay? This is equal to, obviously, this is equal to 10, okay? We have 5 plus 5 equal to 10, but this is not equal to 20, so it's not 1, is not a good root for us. Secondly, let's check, for example, a equal to 2, okay? So we have 5 square plus 5 square plus 5 square equal to, what do we have? We have 25 plus 25 equal to 50. So this is not equal to 20, but we can see that we are go in front of this 20, so we have as a result we have 50. So our root is between 1 and 2. So our inspection method doesn't work right here. So right now let's try to solve this question. Okay, let's try to write a solution and let's try to think about the tricks. How can we solve this? How can we solve this question? Okay, first of all, what do we have? We have 5 to the power a, our equation. Let's write it. So 5 to the power a plus 5 to the power a is equal to 20. Right now, 5 to the power a plus 5 to the power a, we can easily add it. So this is the same thing as, for example, x plus x. When we add x plus x, as a result, we have 2x, okay? And right here we have the same thing, but we have an exponential form. It doesn't matter. We can add it. So as a result, we have 2 times 5 to the power a equal to 20. Okay? Right now, we can divide both sides by 2. Okay, let's do this. Let's divide both sides by 2. From here, what do we have? On the left side, we have 5 to the power a. On the right side, 20 divided by 2. We have what do we have? We have 10. Yeah, we have 10. How can we solve this question? Equation 5 to the power a equal to 10. This is our basic school question in terms of log. We can easily solve this question using log. How can we do this? Of course, according to a log property, we can apply log on both sides. Okay, so as a result, we have log 5 to the power a equal to log 10, okay, log 10. Right now, this a, according to this log property, will come down right here, okay? So as a result, what do we have? We have a log 5 equal to log 10. Okay, right now let's divide both sides by log 5, and as a result, we have our answer. So a equal to log 10 over log 5. And it looks like this is our answer, but I'm going to show you how can we simplify this a little bit, okay? This is our answer, and right here on the left side, right here at this place on the left side, I want to simplify this a little bit, okay? So we have log 10 over log 5. From here, let's continue. So we have a equal to, this log 10, we can write as log 2 times 5, yeah? So we can write it as log 2 times 5. Okay, and a lot of students might be asking why I write this as 2 times 5, and my response is right here we have a really great case to apply this log property. When we have a log of a product, we can write it as sum of 2 logs. Okay, so we have over log 5. Right now we can write it as log 2 plus log 5 according to a log property, log 5, yeah, and we divide it by log 5. Yeah, really great. Right now, this numerator can be divided by log 5. So we can divide log 2 by log 5 and log 5 by log 5. Let's do this. So a equal to, so log 2 over log 5 and plus log 5 over log 5. Okay, right now this log 5 over log 5 equal to 1. So we have our 1 in the beginning. I'm going to write this one in the beginning. So we have a equal to, 1 plus, and right here we can't simplify this more. We have log 2 over log 5. So log 2 over log 5. Right now, few tricks, because a approximately equal to 1.43. Okay, 1.43. If you're interested in approximate answer, a approximately equal to 1.43. Right now, few really important tricks, because right here we solve this question in terms of our real number root, but maybe right here we have a complex root. We don't know about it, but in the second part, right here on the right side at this place, I'm gonna solve this question in terms of complex root. So I'm gonna use this expression. So 5 to the power a equal to 10. I'm gonna write this expression once more. So 5 to the power a 5 to the power a equal to 10. Okay, 5 to the power a equal to 10. Right now, let's see how can we find at this place, how can we find our complex root. So we have 5 to the power a equal to 10. First of all, instead of 5 to the power a, I want to write the next expression. I'm going to write e to the power natural log of 5 to the power a. We can easily do this, e to the power natural log equal to 1, and as a result we have the same expression. But in my case, I really need to bring this a right here, so as a result we have e to the power a natural log 5. So I really need this expression. Instead of 5 to the power a, I'm going to use this one. Now instead of this 10, what do I write instead of this 10? This 10 in terms of our identity can be written as 10 times e to the power I times 0. Yeah, we can easily write it like that in terms of like complex numbers, which is equal to, we have 10 times e to the power I 2k pi. This is our second interpretation. We can easily use this. So this 10 can be written as 10 times e to the power I times 2k pi, and of course we are talking about k from z. We're talking about k from this set. Okay, right now let's do this. So instead of 5 to the power a, we're gonna write this one, e to the power a times natural log 5. Yeah, so we have e to the power a times natural log 5, yeah, e to the power a natural log 5, which is equal to, instead of 10, we're going to write this one. So 10 times e to the power I to k pi. Okay, right now let's solve it. How can we solve this? Right here, I'm going to separate it because this is not our solution. Okay, right now let's apply natural log on both sides. Let's do this. So natural log of e to the power a natural log 5. Yeah, we're going to apply natural log on the left side, and of course we need to apply it on the right side. So natural log of 10 times e to the power I times 2k pi. Okay, really great. Right now, what are we going to do next? Right now, I'm going to continue right here in the middle, okay? So we can easily write this a natural log 5 in front of this natural log, because these are natural log properties. So we have a natural log 5, but natural log a equal to 1, so you don't need to write it anymore, so we need to cancel it. In our head, we need to cancel it. Right now, the log of product, we can write as a sum of two logs. So we can write it as natural log 10 plus natural log of e to the power I times 2k pi. Okay, we can write it like that. And in this place, we can easily, in our head, we can easily cancel our natural log e, and this e to the power, this I times 2k pi, we can write in front of this. So as a result, we have only I times 2k pi. We don't have any natural log of e. So we have a times natural log 5 equal to natural log 10 plus I 2k pi. And of course, at the every places, we need to write that k from this set, okay? From this set. And of course, the last step, we need to divide our numerator by natural log 5. So our a equal to natural log 10 plus I 2k pi, and all over this natural log 5. This is our answer, and of course I'm gonna underline that. I want to underline this as a second root, so this is our a second, and I'm gonna underline it right here. Okay, this is our complex, and this is our complex root, and of course I'm gonna write as an answer. So this is our answer to this question. So a second equal to this one. This is our complex root, and I'm gonna underline. I'm gonna write this one. So this is our a first. Let's write it, for example, on the right side, right? So we have a first equal to this one. So 1 plus log 2 over log 5, log 2 over log 5. And of course, I'm going to underline this a first as well. So this is our first root. This is our real number root. And of course, if you're interested in approximately answer, approximately equal to 1.43. So this is our answer in terms of real numbers. This is up to you. If you need a complex root, of course we can solve this part according to this algorithm, and of course from here you can get a complex root, because we have our imaginary unit. So this is our complex root. And few tricks to this question, because right here we have 1.43 as approximately answer, and we can easily get this answer from this place, okay? From here, because from here, yeah, from the beginning, yeah, because when we plug in a equal to 1, it means that we have 10, so it's not more than 20. But if we have 2, our 50 is bigger than 20, so it means that our root is between, because in our question we have 20, so 20 is between 10 and 50, and of course we are talking about our root is between 1 and 2, because we plug in right here 1, we have less than 20, we plug in 2, which is like bigger than 20. So it means that our root is between 1 and 2, and of course our root is between 1 and 2 because we have 1.43. So this is my solution to this question. I really hope you understand it. I really hope you learned something new. You can also write your thoughts in the comments below. Write your assumption, write your solution in the comments below. It will be really interesting to exchange information. And I want to say thank you everyone for watching. I really hope you get it. I really hope you understand this solution. This is not a hard question. Of course, without this complex part, we can easily solve this question at this place right here. I guess, yeah, we have right here. We can easily finish our solution. But with these few really interesting tricks with the logs, we can get more like great answer, yeah, for you and for your teacher, because you use like few tricks. Yeah, you express it as a product, you express it as a sum in terms of log properties. This is a better answer for you and for your teacher. And of course, the second part with the complex number, that's my thought about this question. So I really hope you understand it. Where can we get this second root? So thank you very much for your time. Take care of yourself. Have a great day. Also write your thoughts, write your response in the comments below, and see you in the next videos. Have a great day.